Your FastMCP server is running operations in the dark. No visibility into what's being called, no record of payloads, and no structured logs for debugging when things go wrong. We'll implement 2 logging middleware layers, one for human-readable operation tracking with payload support, and another for JSON-structured logs that integrate seamlessly with log aggregation tools. You'll see exactly how to capture every detail while keeping your logs clean and actionable. From FastMCP server middleware logging import. Logging middleware. Structured logging middleware. Hash human-readable logging with payload support. MCP, add middleware, logging middleware. Include payloads equals true. Max payload length equals 1000. Hash JSON-structured logging for log aggregation tools. MCP, add middleware, structured logging middleware. Include payloads equals true. This demonstrates the middleware pipeline pattern for cross-cutting concerns in RPC systems. The code shows 2 specialized logging middleware components being injected into the request processing chain, each handling different output formats without modifying core server logic. What makes this distinctive is the ability to layer orthogonal functionality like logging, monitoring, or auth as independent components that wrap the main processing flow. The pipeline works through composition rather than inheritance, with each middleware receiving the context object and a call next reference to continue the chain. This creates a clean separation where middleware can inspect, modify, or short-circuit requests before and after they reach the main handler, while remaining completely decoupled from the business logic. The order of middleware addition determines execution sequence, enabling progressive transformation of requests and responses through the pipeline. This approach solves the problem of scattering cross-cutting concerns throughout your codebase. Instead of mixing logging code into every tool or resource handler, you centralize it in reusable middleware components. The pattern shines in distributed systems where you need consistent behavior across all operations, with the trade-off being slightly increased complexity in understanding the middleware execution flow. It's particularly valuable for observability, security, and performance monitoring in RPC servers. Let's break it down line by line. From FastMCP server middleware logging import. This imports FastMCP's logging middleware components. These handle request, response logging, and structured log formatting for observability tools. Logging middleware. Logging middleware is a request-response interceptor that automatically logs incoming requests and outgoing responses in human-readable format. It captures timing, status codes, and optionally payloads, providing visibility into API traffic for debugging and monitoring. This is the standard middleware pattern for cross-cutting concerns in web frameworks. Structured logging middleware. Structured logging middleware formats logs as JSON, enabling integration with log aggregation tools like Elk, Datadog, or Splunk. Unlike human-readable logs, this ensures machine-parsable structure for filtering, alerting, and analysis at scale. Critical for production observability, where log volume demands automated processing. Closing parenthesis for the structured logging middleware instantiation. This completes the middleware configuration, enabling JSON-structured logs that integrate with log aggregation systems like Elk or Datadog. Hash human-readable logging with payload support. MCP, add middleware, logging middleware. This attaches human-readable logging middleware to the MCP server. It captures incoming requests and responses in a developer-friendly format, including payload contents when enabled, which is critical for debugging API interactions. Include payloads equals true. This enables request-response payload logging, critical for debugging API interactions. Without it, logs would only show metadata like timestamps and status codes, hiding the actual data being processed. The pattern is common in middleware stacks where you need visibility into data flow. Max payload length equals 1,000. This limits logged payload size to 1,000 characters, preventing excessively large payloads from overwhelming logs or log aggregation systems. Practical safeguard that balances debug visibility with system performance. Closing parentheses for both middleware configurations. This terminates the add middleware calls, finalizing the logging setup with the specified payload inclusion and length limits. Hash JSON-structured logging for log aggregation tools. MCP, add middleware, structured logging middleware, include payloads equals true. This adds structured JSON logging middleware for log aggregation systems like Elk or Datadog. Unlike human-readable logs, this format ensures consistent parsing and filtering by observability tools, while include payloads equals true captures request-response data for debugging. Logging duality pattern. FastMCP's logging middleware demonstrates the power of dual output streams, where human-readable logs and structured JSON logs coexist without conflict. The same payload appears in both formats, but their processing pipelines remain completely independent. This separation enables both immediate debugging and long-term analytics without modification to your core logic.
The log that speaks to humans becomes silent to machines, while the log that speaks to machines becomes invisible to humans.